Swift-cut upgrades. I had a customer got in touch with us a few weeks ago. He bought a second-hand Swift-cut, wasn't really getting on with the control system side, so he asked us what we could do. So we've taken out all the existing Swift-cut controls and fitted a new Techserv CNC system in here. So in here is a Dell PC, Techserv CNC software, trio motion controller, new drive amps linked in to the existing machine. Machine's had a bit of a clean, and we fitted a head-up switch, but we've not done a huge amount to it other than that. But now it works the Techserv CNC system. We'll give you a quick look at that. So this machine is now fitted with the Techserv CNC system with a touchscreen interface. So it's got a new monitor. So the touchscreen is nice and easy to use because you don't have to find where your mouse is when you want to press the button and stuff. So I'll just press start. We've got a little drawing here. Oops, press the stop. A little drawing here. We want to make one of these. So really it's a case of how quickly can we make that? So we'll choose a flex shape. It's this generic shape. It's basically 100 by 200. So we'll have a new shape, 100 mm across, 200 tall, and 8 mm lead in length. It's got 3 holes in it. So the first hole is 25 across, 30 up. So add cutout, circle, we'll make these. These are 15 diameter, 15, 25 across on the bottom and 30 up. And add another cutout, which is going to be another circle, 15 diameter. This is going to be 75 across from the bottom left-hand corner, and 30 up again, 30. And lastly, another hole. This is 15 diameter again. This is 25 across, and the other one, that number there is 30 from the top, so 170. Press enter, 25 across, 170. There's our holes, and now need a notch. So the notch appears to be 50 by, so 50. 60 down there, so it's 140. 140. The currently set as a chamfer. We press this button here, it becomes a notch. We'll save this as a L bracket. So we can recall that and edit that if necessary. This sort of shape lends itself quite nicely to being nested together. So we go into mini nest. We can rotate it. I don't need to rotate it at all. We can then move them closer together using these buttons here, and that's fit it that way. Take a bit less material up. There we go. That's pretty good. Next, now if you wanted a load of those, we could then nest them using array nesting. To change the scrap allowance down a bit. So we make a bunch of these if you want. Techserv CNC system has a built-in process database. So in this case, we've got a PowerMax 125 set up on here. So this shows the picture of 125 consumables, shows us the current settings we've got and the consumable types, and we've got a choice of materials there on the right-hand side. So we type in the material thickness we want to cut, 8 mm. It selects the 8 mm category out of the middle there. It communicates to the plasma automatically and sets the current. So we're on 65 amps, but we can see that it'll respond back as it sets the plasma. So this is now set up. It also knows about holes, so it will produce good quality holes automatically. So let's just go straight into run screen. We can see, if we zoom in on these, we can see that the original geometry of the blue line has now been replaced with this white line here, which chooses a fancy lead-in with an arc, straight lead-in with arc, and it gets around to about 300 degrees, 320 degrees. Turns the arc off and keeps going. This gives us a nice finish to the hole. And I've got a sample of one of those here. So this is a piece I cut earlier, a test piece, but we can see the quality of the hole on that. So that's cut at 65 amps That's 8mm mild steel. There's a slight divot where it stops and starts on the inside, but barely perceptible. And the cut quality is pretty good. All things considered, I'm quite pleased with that. Let's hope the customer is. But we don't want all these L brackets, so we'll just make one of these and cut as a test piece out of a piece of scrap. So the machine knows the plate thickness. It's got automatic initial height sense built in. It works a different system to the original. But let's give it a go. Or just jog the head off the job. There we go. Just give it a little bit of a clean up to get some of that the low speed dross off the holes. So here's the finished part. To drawing, those are 15mm diameter holes. Very smooth stop starts, and a nice cut quality all around, really. You can go from simple sketch to finished component in maybe a minute if you try hard enough. The Techserv CNC system's got some cunning algorithms built in which give excellent hole quality. It's not necessary to cut all the holes on the nest first. You cut components on a component by component basis. So this is an inbuilt shape. There's a library of inbuilt shapes which are easy to use, quite a comprehensive library. And these are very flexible shapes, and you make a load of stuff with that. Some people don't use CAD at all, they just use the flexi shapes on the machine. There's a bunch of extra features, such as the ability to, as you're cutting a profile, to stop at any point and reverse back up around the path. So if the cut goes out, you can recover that part rather than having to chuck it away and start again. You can jump through programs, backwards and forwards through programs, select pierces. If you load a nest in, you can cut a complete nest on here, or there's a cut one part button that allows you to just take a piece out of that nest and cut it as an individual item. It's got row and column nesting, as we saw, mini nesting, true shape nesting, manual finger nesting, and it's also got a new thing on here, which is a staircase nesting, or zero scrap nesting, which uses a common line cut. So that can really reduce the cut time and brings the scrap down to virtually nothing. We'll also import DXF files, NC1 structural files. It can read a JPEG and turn a JPEG into a silhouette. It can also, we have a clip on camera that allows you to draw shapes freehand, scan them into the CNC, which you then cut them directly, or you can load them back into your CAD software and edit them as a DXF file. So I'll include a few photographs at the end of this video of the internals of the cabinet, so you can see what the upgrade entails. And there you go.